Hello dear students, how are you all doing? Okay, ready for video number 3 on Lewis structures and formal charge? Of course on the channel pen and paper. Yes, the pen and paper, that's a reminder for you to grab your pen and paper so that you can practice some more structures. Because in video number 1, I've already given you the flow chart for drawing Lewis structures. Easy way, super easy way to know how to draw Lewis structures. In video number 2, we had practiced some examples, and today we are going to do some more examples, but it won't take much time because I know you're confident now. For those who've not seen the video number 1 and 2, earnest request, please watch video number 1, at least video number 1 first, and then go on watching this video. I'll post the link in the description for video 1. Please see that first and then come back to this video. You'll be so happy with the results, I'm telling you. In my last video, I had left you with some food for thought. Did you draw the structures for nitric oxide, sulfur dioxide, sulfur trioxide, chlorate, ozone, and peroxide? It's not O2, it's peroxide. Oh, I made a mistake. O2, 2 negative over here, right? Peroxide ion. So are we ready to check your answers? Let's get started. Nitrogen monoxide, first step done. Total valence electrons, 5 plus 6, 11. Next step, connect them by a single covalent bond. Next step, put the electrons around it. Next step, you have to see if the host is happy or not. Our host is nitrogen over here. Of course, oxygen we've completed. What about nitrogen? 1, 2, 3, 4 and 5. Oh no, the host is not happy. What do we need to do? We request oxygen to accommodate and form a double bond. Let's check now. Is it complete? 1, 2, 3, 4, 5, 6, 7. Still 7. Now, let's suppose I ask this oxygen, the guest over here, to form one more bond. Look at that, what happens. Now, nitrogen will have 9 electrons. Not done, boss. We cannot take that much risk because nitrogen is a small atom. So, my electrons go back to where they were on oxygen. So, what do we need to do now? We need to check the formal charge on oxygen and formal charge on nitrogen. On nitrogen it is 0, on oxygen it is 0, on nitrogen it is 5. That means the number of valence electrons minus the number of electrons as lone pair and minus the number of bonds. Same way for oxygen. So that means if you notice over here, the formal charge on both the atoms is 0. Satisfied, happy. It's a neutral molecule overall, not charged, right? But of course, there are times when this oxygen would like to share its electrons with the nitrogen, right? But then in that case, what will happen? How many electrons will be there? Or it could ask the nitrogen to share. Is it possible like that? Oh, these are all the possibilities that we can think of. And that's what we are going to do in resonance. Sulfur dioxide molecule. Again, I've done the initial steps. Total valence electrons 18. Now look at that. So 6, 7, 8 happy. 6, 7, 8 happy. 2, 3, 4, 5, 6. Look at that. Our host is not happy. What do we need to do? We need to remove 2 electrons from here. And it forms a double bond with one of the oxygen atoms. Now it should be happy, right? If it should be happy, why should it be happy? So 4, 5, 6, 7, 8, 8 electrons. It should be a happy molecule, right? Let's put the formal charge. On oxygen it will be 0. On oxygen here it will be -1. In the previous videos we've discussed. This is quick because we know it now. Formal charge on sulfur, how much do we get? 6 minus 3 minus 2 gives us a value of 1. Look at that. Our host is charged up. Is that the right thing? Is it nice on our part? No, it is not. We cannot leave the host charged. So what do? Again, a request goes to oxygen. Boss, please share electrons over here. It's nice. You cannot leave the host in an angry, charged mood. So what about the formal charge on oxygen? Formal charge on oxygen is 0. And what about the formal charge on sulfur? 6 valence electrons, right? And 4 bonds and 2 valence. Oh, it's super arrangement. Our host is also happy. The guest is also happy. Nobody is charged, and that's what we've got, the final molecule. By the way, are you collecting the well dones? Are you patting your back for getting these structures right? Good, well done, super done if you've attempted these questions before watching the video. Sulfur trioxide So3. I've done the basic groundwork. Total valence electrons is 24. Distribute the electrons, complete the octet. Are they happy? Let's see. 8, 8, 8. What about the host? 2, 4 and 6. Oh, that's a sad thing. So we cannot leave our host like that. What do? Yes, request one of the guests to share their chips packet with the host. Correct. Now let's see. Now it should be happy. Check the formal chart. O -1, O -1, O 0. Formal charge on sulfur. 6 take away. How many bonds? 1, 2, 3, 4. 6 take away 4. What do we get? Charge is +2. The charge on each of the oxygen is -1. So +2 -2 gives us a 0. So it should be a happy proposition, right? No, it's not right, because our host is charged with a good positive charge, and you know that our host is a big-hearted person, a person with a big house. So what do? We ask one of the oxygen again to share its electrons. So when we do that, now what is the formal charge on sulfur? 6 minus 5, that's again 1. It's not nice. Third guest also, please pitch in. Our host is crying dearly. So what happens? The third oxygen also shares its electron pair with the host, that is sulfur. So what do we get over here? 1, 2, 3, 4, 5, 6. Wonderful. 6 take away 6, 0. Everybody is happy. It's a molecule where everybody is happy. And by the way, you notice in all this, it's not a bad deal for oxygen. All the oxygen have a formal charge of 0, and their octet is also complete. Right? Okay. That's a new molecule for us, right? Chlorate. Of course, chlorine is in group 17 of the periodic table. So 17 minus 10, that gives us 7. So fluorine, chlorine, bromine, iodine, astatine. So we've got 7 electrons in the valence shell. So 7 plus 18 from the 3 oxygen plus the negative charge. So we get a total of 26. Let's distribute them. 8 times 3 is 24, 25, 26. Notice the chlorine having the lone pair of electrons. Now let's see, is the octet complete? Yes, yes, yes. What about this? 2, 4, 6, 8. Perfect. So it should be a happy family, right? So let's see the next thing. Yes, don't forget the work is not yet done as yet. So we have the formal charge, -1, -1, -1. What about the formal charge on chlorine? So we have here 7, take away 3 bonds, take away the 2 electrons in the lone pair, and I have 2. Again, the same scenario. Our host is not happy, so we ask 2 of the guests to spare their chips packet and give it to the host. Share it, not give, sorry. So they share it with the host. Now let's check what is the formal charge on chlorine. Of course, the formal charge on the 2 oxygens will change. How much will that be now? Yes, it's going to be 0 here, it's going to be 0 here because they are already forming a double bond. What about this oxygen? Of course, the third oxygen will have a formal charge of -1. What about Cl? So you notice over here 7 valence electrons. 1, 2, 3, 4, 5. 5 bonds. And 2 electrons in the lone pair. Well done. You gave it a stable configuration. And there we go, another well done for you if you made an attempt to draw these structures. If you have not, then there is this complete list of structures that you can try yourself. Or go to video number 2. So many ions have been done as practice ions. Go ahead, try them yourself. The next one to be done, peroxide ion, O2 negative. This is an interesting ion because peroxide ions are going to be used when you talk about the free radical mechanism, right? So again, let's go back to total valence electrons. So we have 6 times 2 plus the 2 negative over here, and I have 14. So distribute 6, 7 and 8. 6, 7 and 8. Oh, this should be happy, right? What do we need to find out now? The formal charge. Do you really need to find out? Okay, if you want to. So -1, -6. So we have a formal charge of -1 on each of the oxygen, and that is what makes it reactive also. So if you notice over here, they've got -1. They are hungry. They are not yet happy. They are short of electrons. In order to be satisfied, they need to nullify, right? So they want electrons. Let's go back to the next one, that is ozone. Simple? This is simple, yes. Okay. So total valence electrons 6 times 3 is 18. So again, any one of the oxygen is the central atom. 6, 7, 8. 6, 7, 8. So 8 times 2 is 16, 17, 18. Electrons are full. So this should finish off the structure. No. Why? Because we are yet to talk about formal charge. What will be the formal charge on the oxygen? So it's a -1 here, it's a -1 here. And what about the formal charge on central oxygen? Go ahead, calculate 6 minus the 2 bonds minus the lone pair. Oh, look at that. It's a 2. Is it nice? So here oxygen is the host for the 2 oxygen, right? So it's playing a host to its own siblings. So what do? Can't leave it like that, correct? It's not nice. So what do? Yes, a request. Even the children can accommodate, right? So we have a double bond over here. Let's see what's the formal charge on this oxygen. So the formal charge on this is 0. the formal charge on the central oxygen. So 6 take away the 3 bonds minus the 2 electrons of the lone pair, and we have the formal charge as 1. So you see over here there's a formal charge of +1 and we have a formal charge of -1 on the oxygen. Can you tell me, is it okay for this oxygen? Would it be possible for this oxygen also to form a double bond? So can I do something like, remove the lone pairs, and now it should be a happy thing for all of them, right? So something like this kind of a structure where our central oxygen is forming 2 bonds here, 2 bonds here. Is it possible? Think. To which category does oxygen belong? Yes, oxygen is in period number 2. So period number 2 means it's a small house. So it cannot form bonds. It's already over its limit. So with the result, what will we do? We won't touch the electrons over here. It's already crossing its limit. So that is why here the charge will be +1, here the charge will be -1, and overall the charge on the molecule will be 0. Now interestingly, if it can form a double bond like this on the left hand side atom, we can ask the right side sibling also to share, right? So we could have a structure like this. I could have drawn the structure like this as well. So 2 electrons over here, whereas the left one says I'll keep my electrons with me. Yes, so there are 2 possible structures for the molecule of ozone, and these are what we call as canonical structures, the phenomena of resonance. Correct? So another well done, should we say? Very good, very good. And scroll down, go down to the comment section and let me know how we did in this video together. How did we do in this topic together? There's immense joy in sharing knowledge, and I'm so happy that I've been blessed to do that with you all. Please pass the baton on and share this gift of knowledge with your friends and classmates who may be keen to learn but may not be finding the correct resources. But most importantly, maintain the social distancing, stay safe, stay happy, and take good care of your health. See you in the next video.